Okay, so let's look at the random response method for questionnaires. So, random response methods are basically a way of getting people to be honest when you ask them sensitive questions like, have you ever cheated on a partner? Have you ever cheated on a test? Have you ever gone to a country illegally? Have you ever avoided tax? Stuff like that. Questions that you don't want to answer truthfully because it might get you into trouble. And this random response technique that we're going to look at in a second will help, hopefully, reduce the amount of people who lie when you ask them these sort of questions. And the reason why they're less likely to lie is because if you use this type of method, a random response, you're not really able to tell who is telling the oh my god, you're not able to tell if someone, for example, has cheated in an exam or they've just ticked yes because they were told to tick yes. That will make more sense in a second. The question we want to deal with is, why would it be difficult to estimate the proportion of people who have cheated in an exam? Well, think about this. You're a student. Your teacher who marks your test asks you if you cheated in an exam. Why would you tell her that you've cheated in an exam? That will just get you into trouble. However, with this random response technique, she may not know who cheated on the exam, but she can estimate how many people cheated in the exam. So, if you ask people directly, they may not want to give an honest answer. You can improve your chances of getting an honest answer by to a sensitive question using a random response. Yeah, basically everything I've said is listed down below. So, let's have a look at random responses. We have, suppose you have 300 people to ask. Suppose you ask 300 people the answer to the question and 75 people tick the yes box. Here is the question we have. Roll a die. If the die shows 6, the box mark, then tick the box that is yes. If the dice doesn't show 6, answer the question. So basically, you roll a 6, don't even read the question, just tick yes. You don't roll a 6, then you read the question and answer honestly. So, we know the chances of landing on a 6 on a die, on a fair die, we're going to assume, is a 6th. They've asked 300 people, so we're expecting a 6th of these 300 people to have just landed on a 6 and tick yes. So I'm going to take a 6th of 300, and that gives me 50. So what we think about this 50 is these 50 people just landed on a 6. Okay? We know 75 people ticked yes, so if I do 75 and I take away my 50, what we're estimating is that 25 people have cheated in an exam because we're getting rid of the 6th chance. The 6th of the 300 people who we're expecting to have just landed on a 6 and ticked yes anyway. So we'd have 25 left over who we think actually cheated. Okay. So 300 is the people you've asked, but that includes the 50 who have just ticked yes. So we're going to get rid of the 50. And what that leaves us is with 250. This 250 is basically people who actually answered the question. So people who actually answered instead of just ticking yes because they landed on a 6. And if you want to, what you want to do is you want to work out the proportion of people who have actually cheated on the exam. So we know 25 cheated, and we know 250 people actually answered the question. They didn't just land on a 6. 25 out of 250 is exactly 10%. So from this random response technique, we have estimated that 10% of people who answered the question have cheated in an exam. So let's look at another question. Actually, let's dive into more detail just in case you didn't follow. So, suppose you ask 300 people, same question as we had before. As we said, we expect a 6th of people to roll a 6 because you have, in your sample space, you have either 1, a 2, a 3, a 4, a 5, and a 6. 6 only appears once, so the probability of a 6 is 1 out of how many? 1, 2, 3, 4, 5, 6. 6. So the probability of a 6 is just a sixth. So we're expecting a sixth of the people to roll a 6. And out of 300 people, that means 50 people just tick the box because they landed on a 6. That is a sixth for 300. 75 people ticked yes altogether. So if we get rid of the 50 people who just ticked yes because they landed on a sixth, 25 people so if they landed on a 6 even, 25 people actually cheated. And if you get rid of the 50 people who didn't actually answer the question, they just landed on a 6, you have 250 people who actually answered the question. So there you have 25 people cheated, 250 people actually answered the question, and you get 10% of people cheated. Okay, let's look at another one. 250 people were asked this question. 148 ticks the yes box. Toss a coin. If the coin shows tails, tick the yes box. So already I'm thinking you have a 1/2 chance of landing on tails if it's a fair coin, and we're going to assume it's a fair coin. If the coin shows heads, answer this question. Do you watch pirated DVDs? So illegal DVDs, basically. Estimate the proportion of people who watch pirate DVDs. Give your answer to the nearest whole number. So we have 250 people. We're expecting around half of them to land on a tails and just tick yes. So we're expecting 125 people to just land on tails and tick yes. So if I take my 148 people who ticked yes and get rid of the 125 people who we're assuming just landed on a tails, we have 23 people who actually watch pirated DVDs. And if I take my 250 people and I get rid of the 125 people who landed on a tails and just ticked yes without reading the question, we get 125 people. So 23 people have ticked yes. 125 people have actually answered the question. And 23 out of 125 is 18.4%, which they want to the nearest whole number, so 18%. Okay, another one. 270 people were asked this question. Toss a coin. If the coin shows tails, tick yes. Well, it's the same question, it's just different numbers. So 270 people asked the question. And obviously, if you toss a coin, you'd expect half of people to land on tails. So if I do 270 times a half, 270 times a half, we get 135. And if I do 157 minus 135, that will tell us the people who we think actually answered the question and ticked yes, which is 22. And if I do 270 minus 135, I'm going to find the people who actually answered the question altogether and either ticked yes or no. So we believe 22 people ticked yes and meant it, and we believe that 135 people actually answered the question. So the proportion of people who watch pirated DVDs is 22 out of 135, and 22 out of 135 is 16% to the nearest integer, or nearest whole number. So it's 16%. Okay. So I want to show you this formula that might be helpful to some people. What we did is we logically broke down how to estimate a random response. But when you get good at it, you can use this formula. And the random response formula is your observed minus your expected over your total minus expected. So let me copy that down so I can show you what I mean by that. Okay. I'm going to put that here. Observed minus expected, wrong thing. Observed minus expected over total minus expected. Well, we've observed 172 people have ticked the yes box. And they're tossing the coin, and if it lands on a head, on a tail, then they've just ticked yes. So we're expecting half of the 300 people they've asked to just tick yes. So we're going to get rid of it. And then we have our total, which is 300. And we want to get rid of the people who we just expected to tick yes because they landed on a tails. So that's going to be half of the 300. And that, straight away, will tell you your estimates. I'm just typing it into my calculator now. And that has given me 15%. So 15% of people watch pirated DVDs. And let's have a look at a final example using the formula observed minus expected over total minus expected. So observed 145 people tick the yes box, and we expect half of the 240 people to have just ticked the yes because they've landed on a tails, because we know the tails is a half chance. And then our total is 240 people because that's how many people were asked. But we want to get rid of the people who probably just didn't read the question because they landed on a tails. So we're assuming it's half of 240. And then if you type that into your calculator, which I'm doing right now, 240 over 240 minus 120 times by 100, I get 21% to the nearest number, whole number. And that is the random response technique.